Well, good morning, good afternoon, good evening, whatever it is for you. Welcome to Using Data Literacy to Drive Insight, a presentation of the Storage and Networking Industry Association's Cloud Storage Technology Initiatives. My name is Jim Pfister. I'm a contractor for SNIA. I run my own company, The Decision Place. And why don't you say hello, Glenn?
Hello.
All right, Glenn Bowden is Chief Architect of AI and Data Science Practice at Hewlett-Packard Enterprise. So we'd like to thank you for coming today. First, we'll get a little housekeeping out of the way. The material contained in this presentation is copyrighted by SNIA unless otherwise noted. Member companies and individual members may use this material in presentations and literature. Obviously it's copyrighted by SNIA, but we would like you to use it and use the information that you get today. Neither of us are attorneys. Nothing in this presentation is intended to be legal advice or the opinion of a counsel. If you need legal advice, I would certainly suggest that you seek that on your own. And this is our personal opinion and our current understanding of the relevant issues involved. So we're not assuming any responsibility or liability for damages, warranties expressed or implied. I'll give you a little bit of a tour of the Bright Talk itself. You can see you're likely looking at this in a very small screen, but if you look at the bottom of the presentation material, you will find some buttons that you may use yourself, and one of those will expand the screen. We do have some minute detail on some of the slides, and I would recommend that you could that you expand the screen if possible. However, we also do have attachments and links available, and this presentation is actually already available for you to download, so you can look at it that way as well. And then SNIA, at a glance, we are 185 industry-leading organizations with over 2,000 active and contributing members, and we reach out to over 50,000 IT end users and storage professionals worldwide. We're focused on providing information that's beneficial to the industry, and we hope that you enjoy your time today. SNIA will educate, support, and promote, help you understand what's going on in the industry and give you the latest information, and we're always willing to collaborate. If you're not familiar with SNIA, you can look at us at SNIA.com, and we're always interested in new members joining and contributing for us. So Glenn, I'll hand it over to you now, and I'll be asking some questions. Audience, feel free to ask questions at any time in that chat, and I will pass those on to Glenn as they are relevant. Go ahead, Glenn.
Perfect. Thank you, Jim. And hello again, everybody. So what we'd like to cover today, as Jim said, is around data literacy, and it's a topic that's it's certainly close to my heart, and it's been brought to the fore a little bit by things like the pandemic and the data that goes along with it. So we'll be exploring that a little bit. So let's first of all kind of step through the topics we'd like to cover. So firstly, I want to describe my view of what data literacy is. And again, this is my opinion, so I'm not suggesting you necessarily share my opinion, but it will set the basis of the rest of the conversation. And this is what I mean when I'm talking about data literacy. I'll then have a little bit of a walk through the data of the pandemic and why this has kind of brought us to the point where it's useful to understand data literacy and why it's an important skill to have and how it can help you interpret things in the world around you. Part of that will be understanding where data comes from. So that's understanding the data provenance. So if you know anything about the art world, you know a picture or a portrait has provenance around it. That's where it's come from and where it's transitioned through before it's reached your hands or before you're viewing it. The same thing is true of data. So we're going to explore a little bit around that. And then we'll have a look around the power of data aggregation. So what happens when you bring two data sources together? Is there an explosion of information? Do you ruin things? That kind of thing. And then we'll have a quick look around clean versus raw data. And this is really a kind of a data science term to a certain degree, but it's important to know the difference, and it's important to know how to interpret each of those data sources and those types of data that you come across. We'll be doing a little bit of critical analysis throughout, so there's no kind of section on critical analysis. I'll mention it as we walk through and how we can apply that to those various types of data as we move through the piece. And then we're just going to wrap it up. As Jim said, I'm more than happy to answer questions as we go through, so that we can keep it as lively and interactive as you like. There is a ton of information in terms of small diagrams and things like that, so if you can't see anything or need something explaining a little bit more or calling out, then feel free to ask that as a question, and we'll make sure we go back and cover it. So, stepping in then. Firstly, let's talk about what is data literacy. And as I said, this is mostly my definition, but I've tested it with peers and I've tested it with my colleagues internally as well. So it seems to be sort of standing up to those sorts of tests. The other thing I want to look at as well is who needs to be able to be data literate? Who needs the skill set that we're going to describe? So first of all, let's start with the what. At the top line, it's really the ability to create, read, understand, and communicate data as information. So how do you apply context to that data? How do you interpret that data to actually mean something? So it's not just raw data and a bunch of numbers. It has meaning. It can drive an outcome of some sort and add value to a conversation or a decision-making process. So data literacy is really the ability to interpret data in the context to which it's intended to be interpreted. The second part of that is how do you assess the information by looking at multiple data sources? So if you've been offered one data source, how do you know where else to look to find supporting information or information that may even challenge the data that you're viewing? Thirdly, it's applying external context to the data set. So when a data is presented to you, it's usually presented in a form of context. And we're going to have a look at some of those. We'll use a pandemic as an example about how some of that information gets presented. But it's important to understand the impact of that context on the data and the interpretation you make of it, how it can change the point of view very drastically just by having a different context. And then how do we ask the right questions of the data? And this is really a kind of data scientist view, if you like, about when we have data, what do we need to do with that data? And there's two parts of asking questions. There's the asking the question of the data for the answers you're looking for, but how do you question the data's authenticity and the data's provenance as well? So we're going to go through some of that. So let's talk about the who. So who do we have, or who typically will have data literacy skills? Now, data scientists and data engineers, they're kind of the people you'd expect to find on this chart, right? It's the first and the most obvious. They must have these skills because they need to understand the data sources, and they're the ones that are building algorithms and models and code that actually extracts analysis and information from that data. So absolutely, that's a no-brainer. Information architects, and what's the difference between a data scientist, an engineer, and an information architect? Well, the information architect's job is very much to design the data that flows through an organization. And what they do is they're responsible for the discovery of that information, the tagging of it, the indexing of it, so you can find things and search through it, as well as the kind of schemas that they're held in. And that could be a directory structure in kind of unstructured data, or it could be database schemas in terms of how it's being stored. So they're really the architects that decide how that data is persisted and manifests itself. Operations engineer. So this is a strange one, and then you're looking at the first two and then probably looking at the IT ops as the third and thinking, well, they don't really need to understand the data. They're more looking at the infrastructure that supports the storage of the data and those sorts of things. Well, actually, an operations engineer must have a very keen data literacy skill. And the reason being is they're absolutely bombarded with things like logs from applications, from infrastructure, alerts coming from SMP traps, and all those sorts of things. And it's their job to be able to determine the truth that's being presented to them from that data. So you absolutely must have a skill set that allows you to analyze which log is the most relevant to that particular time, apply context to that log so that you know which log lines are actually important or which ones can be discarded because they're irrelevant and caused by something known. So an operations engineer absolutely must be data literate for the data sets that are important to them. And finally, technical decision makers. And what I mean by that is a lot of the times you'll get given RFPs and RFI responses from vendors such as myself even. I've written a fair amount of those. And you need to be able to interpret them in a way that's meaningful for you. So how do you take the data that's presented in the context of a vendor that's technically trying to sell you something and actually get to the bottom of the truth, as in what's relevant to you, what actually maps to the questions that you're asking at that RFP, and what is marketing versus what is the actual data truth and things like performance benchmarks, those sorts of things. So technical decision makers need to be data literate as well so they can apply context to the data that's being given to them before they make those decisions. So those are kind of four key personas. Obviously, it's a limited scope because there's more. And in fact, what you'll find is everyone can benefit from data literacy. We all have information bombarding us all of the time, be it from the internet, be it from the press, be it from our politicians, be it from our colleagues, our friends, everyone. will provide you with information, and it's down to you to understand how to process that information. And if we lose the skills of being able to challenge that data and challenge that information and ask questions of it, then we're just blindly accepting everything that's told to us, and suddenly the world becomes a very confusing and quite scary place if that's the case. So everyone needs this data literacy skill to different degrees and to different emphasis, but I think everyone should have this as a basic skill.
Glenn, I'm going to certainly emphasize that, and we can bring back one of the first examples of the pandemic. One of my many volunteer activities is I sit on the civilian oversight board for our local public safety. And while we got a lot of information from the local government and from the state government and the federal government here in the U.S. on various aspects of COVID, we really had to understand how that was applying to our very regional, public safety actions. And so, I picked up a lot of statistical analysis skills trying to look at case rates and infections from the information given to me, and then trying to break those down into, the local zip code, the local responses that we need to do. So I absolutely agree with you that everybody can benefit from being able to look at data and actually apply it to what they do in a regular way.
Absolutely. Thanks, Jim. That's a great example, and leads us very nicely into the next bit. So I got particularly interested in making data literacy a wider topic during the pandemic. So when I saw the kind of data that was being thrown at members of the public, as well as at organizations, and being able to understand, interpret it, and act quickly on that information, I thought it was an incredibly challenging time. Obviously, it was a very challenging piece of data processing that had to happen in order to kind of get to that point. And so that's what kind of made me passionate about evangelizing this almost. So looking at the pandemic, what sort of data actually was being thrown at people, and how could that have been interpreted? So we'll start from the very simple stuff, and I apologize, I know it's quite small, so click the buttons and make the screen bigger if you're able to. COVID-19 absolutely bombarded the public with more data sources than any event in history. It's the most widely data-sourced event we've had. So even if you look back at kind of major conflicts and things that have happened in the press, they weren't at the same level of data availability as the pandemic has been. And that's largely through research organizations, public sector organizations, anyone that's had any kind of involvement in this has been open and shared it, because they've realized that the only way to get on top of the challenges we're being presented with was to collaborate around those data sources. And so they were made freely available. There was no competition of penning them in. There was nobody trying to say we need to get somewhere first, and so we'll sit on all the information we had. It was absolutely in the best interest of everybody to share everything. What that's meant is that we had a plethora of information that suddenly became available that we then had to wade through and understand. So what types of information were we getting? Well, we were definitely seeing statistics on infection rates, deaths, R0 numbers, and it may be the first time many members of the public understood what R0 actually was. In fact, we've got many governments that have just shortened it down to R now. Unless you've seen sort of films like Contagion, which kind of give you a good background on that. But we were seeing sort of information in graph format and in historical trend analysis, and we were seeing sort of linear curves and those sorts of things for the first time sometimes. And it was difficult to understand exactly what the trend analysis that we were being shown meant. And I certainly know members of my family and friends that I know that are outside of this industry and outside of data that were struggling to understand what some of the graphs they were seeing meant, and what flattening the curve meant, and those sorts of things. So there was a real kind of realization that too much data could be a bad thing as well. We saw clinical data, and that was comparing COVID-19 with pandemics of the past. And again, there were two different contexts being compared with each other, and not always on equal footing. So a lot of the press were taking things that happened in 1918 and the flu, for example, and comparing them with COVID-19 without necessarily correcting for different trends. Things like the number of people that lived in an area, the population. If you were looking at pure numbers, one looked far scarier than the other. If you looked at percentages, that flipped on its head. So there was different ways that those things were being presented depending on the motivation of the people that were presenting the information. We saw medical data on pre-existing conditions and risk. So this was looking at the state of an individual, so whether you had a pre-existing medical condition, whether there was a particular health aspect around you, or whether there was something in your community, or even your race or your financial position, what impact it meant that COVID would have on you, either through being ill or through an economic restriction of some kind. We saw cultural data on which communities might be impacted more. And this was more around when you look at the communities that were being impacted by COVID, which ones were going to be hit the hardest? Lower incomes, obviously, were massively impacted. And so the areas and the communities that were predominantly low income were at huge risk from economic failure, even if not from the infections itself. And we saw a lot of graphs and charts figuring out how do we actually leverage that information to be able to get the right help to the right people. That goes into the economic data that we saw. And that was not just from the people and the individuals. The economic data then got broader. So how are the companies going to survive? How are the actual economies and the business areas and the various verticals going to be impacted by the lack of supply chain, the lack of customers, all of these other things? And we see political data, largely saying why we should ignore the other person's political data. So, but the political data does add skews to the data that you're seeing. It's a context with a particular motivation again, and we'll look at how that sort of plays out in a bit. And the question we have to ask of this is, how much of this data is information? So how much is actually substantiated by the facts, and how much is being presented as, here's the data and the information that you need to digest, versus how much of it is opinion? And there's a surprising amount that just comes in as opinion. And bear in mind, opinion is somebody else's interpretation of that information, removing what they see as irrelevant and placing in their own relevancies. Now, that's not to say that an opinion is wrong, but you need to bear in mind that there's other factors that kind of cloud the judgment or cloud the outcome of that information.
You know, what really I thought was remarkable was the variability of the data. Largely by region, but just the variability of the data sources and the change in data over time. And that, you know, a lot of that was very likely driven by test methodologies or testing, but just being able to look at data from one region and apply it to the other was very difficult given just the different methodologies that were going on.
Absolutely, that's a great point. And one of the kind of key differences that we see is in a geography or an area's ability to actually do that data collection and processing. So you would look in the UK, for example, and it looked like we were getting much better every weekend. And it's purely because of the fact that offices were shutting down at the weekend that were doing that data processing. So the statistics simply weren't making it back. So if you look at a daily trend, Saturday and Sunday looked really great. And then suddenly Monday, there was a huge peak when the data processing caught up and processed from everything from over the weekend. So absolutely, there are differences in the way all of the geographies and all of the regions actually collected their data. And so there's processes you have to go through to normalize that in order to be able to do those comparisons accurately. Absolutely right. So we want to talk a little bit about data provenance. And I'm going to throw up this eye chart in order to do that. This really describes what I mean by data provenance. And there's lots of different models, and I have absolutely oversimplified this, so no need to shout at me in the comments and say, actually, you're missing X, Y, and Z. This is a simplified version on purpose. And what we're looking at on the top is kind of medical data. So you have a sick person, so somebody that's contracted and tested positive for the disease, for example. They have medical data. That's the telemetry that's coming from that person. That's things like heart rate, temperature, blood numbers, all those sorts of things. So the actual data around the condition of that person. That data then goes through a doctor. So the doctor will do the interpretation of that data and write a patient report. And they will also do the prognosis and the care plans and all those other bits and pieces that are important in getting that person well. That will happen in multiple patients across multiple doctors. But they'll all create those patient reports. Now, they could be in the same format. They could be in different formats. It depends on the hospital you're in. It depends on how you're being treated and who's caring for you and doctor style even. Those reports then get consolidated within a hospital. So the hospital records department is responsible for taking all those reports, and they may have a department that then will summarize those. So they'll take the outcome from those reports as they see it, they'll do some interpretation of their own, and then they'll create a summary report. That summary, not the raw data, but the summary, then gets sent as a hospital report to a regional health care. So in the UK, that would be an NHS trust, for example. In the US, it could be a health organization or hospital with a group within the US. So the reports get sent to that health body. Those health bodies will then create regional reports. So they'll take multiple hospitals or multiple areas within the geographies they're responsible for, and they'll create summaries of their own that say, in our geography, in our region, this is the type of impact we're seeing. These are the kind of medical statistics we're seeing from all of the sick people. So when we put all the telemetry together, this is our view of what's happening. And that will go to a medical leader, and that could be somebody from the World Health Organization. It could be a head of the hospital. It could be a somebody that's part of the government that's responsible for the health organization, health planning. But it's usually it has to be somebody with medical training, so a doctor that's able to interpret the summary that they're seeing. They then create more reports, and you'll see that they then release press releases to inform the public of what's going on, and they'll inform the political leaders. So that could be the people that are standing on Boris Johnson or Donald Trump, or whoever it may be in your area, so that they can then go and tell the public about what's going on and what to expect, and make decisions about how to deal with those things. I'm not going to make any political statements, so don't worry. So all of that is how basically the information gets to us as people. Now, on the bottom lines, we've got what's going on in the research and development area. So the pharmaceuticals, the universities, the academic places. When they start doing experimentation to figure out what is the impact of this, can we actually understand the DNA structure of the disease we're seeing? What do we need to do to it? Or can we test cures? Can we test vaccines? All those sorts of things. So every experiment will then have medical data of its own that it produces, which goes to a group of researchers. They do the summarization of that and create a research report. That then goes to potentially a data scientist or a medical leader who can then do more work on it. So the data scientist, for example, might get historical data, combine it with the data they're seeing from the research reports, and create a data report that will show this is the likelihood of this being a good vaccine or a good cure or a terrible cure, whatever it may be. It also goes, as I said, to the medical leader who will make that same kind of interpretation. Those data reports are also made publicly available usually, so the press can come across those too. So not all of the information that the press is getting is coming through the filter of a medical expert. So if they're just getting those reports themselves, they're free to interpret them however they want. What you then find is from the press, snippets of that get released on social media. So largely to drive people to go and read the actual press, but also people just copy and paste because they're either worried about what they're seeing and want to share it with their group, or they're impressed by what they're seeing. There's an emotional impact from what they're reading in the press, and they want to share it on social media, removing all context whatsoever. So you no longer have the medical filters, you no longer have the political filters, you no longer have the expertise that's necessarily present in the report, and you don't even have what could be balanced reporting. What you end up now is opinion and selective editing that's seen on social media. So you can see it's quite a diluted sense of the data, if you like.
What impresses me the most about this is the amount of bias that can actually be put into this. I mean, obviously you look on the right side and you see, and as you talk to social media, the press, the political leaders, even the medical leaders, there's going to be a lot of bias and interpretation that's put in there, but that's also going to come from the data scientists. That's also going to come from the researchers and the doctors. So it's the information is contaminated, the right word, at almost every step of this, and you have to find ways to be able to filter that to get it back to the basic level of information, correct?
Yeah, absolutely. I mean, we call it data pollution. So every time somebody applies a filter to it of some kind, they're taking the resolution of that data down a degree. And what you need to do in order to kind of qualify the report that you're actually getting at the end of the day is determine how much trust you place in the individuals to make that aggregation. So do you trust the doctors, then do you trust the data scientists, do you trust the medical leaders and the political leaders, or your group on social media and the press? So there's definitely trust that gets applied across all of this frame, and you need to understand the path the data has traveled through in order to make those sorts of calls. So absolutely. So if we move on, the first piece was really what should happen. What actually happens is we bypass sections of that as well. So we're assuming, because the right model is that everything goes to the medical leader who will do that interpretation and then feed the political leader the correct information, who will then go to the press, who will make the interpretation properly, and then onto social media where it gets distributed through the public. That's actually the best model. What we then tend to see is those reports are going directly to political leaders, or they're going directly to the press, or they're bypassing the press altogether and the political leaders altogether and going directly to social media for people discovering things on the internet. So suddenly a lot of those filters that can add the subject matter expertise to that data chain are cut out. But the assumption may be that they are still part of that chain. So if you're receiving information directly from the political leader who's gone to Twitter or Facebook to share their opinion of things that are going on, the assumption is they've got that information from the political leader. The truth of the fact is they may not have. And so we need to ask that question, is what is their source of the information? Are they interpreting something that's been told to them, or are they interpreting something that they found? And the same is true for the press, the same is true for the data scientist. There's no reason to trust the data scientist any more than the medical leader or the political leader if you don't think that they're in the position to be able to make that judgment call on what to filter. So we can see that actually it's a lot messier than really we would like it to be.
Yeah, to summarize that, reality is an amplifier of bias.
Absolutely. Yeah, that's a perfect way of putting it, actually. Thank you, Jim. And then, of course, there's you that's stuck right in the middle of all of this, and you also have access to the internet and can go and find some of this data yourself. So you have the ability to go and check the homework of these people, but do you have the expertise to understand how to go and do that and how to interpret the data that they've got as well? And all of these people will be throwing things into that combined data of the internet. There'll be publications coming every which way but loose. So you really need to kind of understand, how can I check the sources of this? How can I go and ask the right questions of the data, which is what we're going to get onto next. So what I wanted to talk about a little bit is the power of data aggregation. What we talked about in that last section is really one data source moving forward, being filtered a little bit and summarized, and then being moved on until that single piece of data meets you in some form or another. But what you can do at that point is then start aggregating. So each of those stages, there is aggregation that's happening, but you have no control over that. When you do receive the information, you're then in control of the aggregation that you can do to it to either enrich it, better understand it, or fact check it. So let's go back again to the very basics. We have our sick person on our medical data. There'll be some historical data as well, so patients that have previously had the condition, and there'll be experimentation that's going on that produces its own medical data. So all of these things give us an understanding. So the raw data comes across and it tells us, the historical data tells us what happened, the sick person's medical data tells us exactly what is happening, and experimentation tells us what might happen. So we have a good idea of kind of, from a single data source, past, present, and future. We then move on to prediction, and we do that by combining all of those things. So we combine the data of what happened with what is happening. We make a judgment call saying, we think this is the path that's actually happening. Then we look at experimentation that's been going on, the data that's in there, as well as what's happened in the past, or some historical data from that too. And we'll be able to predict, if we bring in the context of these three pieces of information, if we bring them all together as an aggregation, we now bring our focus in and be able to decide what might happen in this specific case, in this scenario. And then we move on to prescription, which is knowing what we know about what might happen, what should be done, what's the next stage. And this is a process a doctor goes through. They're not just looking at your medical data, they're looking at what's happened from reports and research, as well as what's happened historically. And so the prediction piece is the doctor's piece. They take the data, they create the prediction of what might happen, and then they'll create a prescription. And I don't necessarily mean going and buying some drugs, but they could create the prescription of what should be done. So do you need to go to hospital? Do you need to be treated in some way? Or do you just need to go home and rest? So that's a good example of, very simple example, but a good example of aggregation. So how do we do aggregation? What is it exactly? And it's really about seeking out supporting data. So when you look at the big diagram we had of data flowing from the left to the right through all those different personas, what we receive was generally only summary data. And that's all that's usually provided for public consumption, because there's no time to go and get a medical degree in order to be able to interpret the detailed data and understand it. There's no point, and we're not all experts, and nor should we be. And that's just one thing. We're just talking about what's going on from the COVID-19 perspective here. If you start looking at what's going on from the fires in California, or from earthquakes, or from weather conditions, nobody's got the time to go and train in each of those subjects and become an expert in it. So even if you wanted to become an expert in the one piece of data, you're never going to cover everything you need to understand. So we're all going to consume summaries, and we all have to trust the process of how the summary got to us. But when you see that summary, the first question you should ever ask is what's been left out, and why was it left out? Because what gets left out of data is what usually creates the bias. It's not necessarily what's been put in, it's what's been left out, and you need to ask why it was left out. So somebody has decided that a certain piece of information that was created as raw data is no longer important, and they've discarded it. So the first thing to ask, why was this piece of data left out, and what was it? Then, does any more data exist that supports or challenges the conclusions? So when you're being presented with something in the press, you'll very often see that there's a balanced story that's presented alongside it to say, this was this opinion, here's the counter opinion to that, and the data that supports that counter opinion. depending on where you're getting that from, it may be worth going and checking other sources as well, because people are in charge of putting that information out there. Editors in newspapers, politicians, medical experts, whatever it may be, they have a motivation to do that. So go and seek somebody with possibly a different motivation, but similar credibility, and see if you can challenge that opinion or that position. We make assumptions about the data. Challenge every assumption that you make when you're reading that data. And we do it subconsciously. When we read data, we assume that, this, and this has obviously happened in order to create this piece of data. Where possible, go and challenge it. That's what the role of a data scientist. When we see data in an organization, we go back and say, well, how was this gathered? Why was this gathered? What was the original purpose of this data? And how come you've made this interpretation from it? So you ask those questions. Additionally, data refines the context or can drastically change it. So as you get that external data, you can be then in a position where I've now changed my point of view because the context has changed. And I'll give you an example, and this is hopefully a humorous example. I do a lot of work with regular police forces, some around the UK, some in different areas. And we were working with one on assessing impact of telephone calls that their operators were taking, and how were they spending their time, essentially. And one of the things that we did was we processed all the data that they had in their call center around where the operators were spending their time and how much time was spent on each call and what was that call about. And we were seeing peaks in demand on the operators, so leaps in the amount of calls that were coming into the call center at certain times. And so we overlaid data in order to try and provide some extra context to that. So look at the day of the week. Fridays and Saturdays normally a bit busier. Okay, that's understandable. People are off work. Good. But we were seeing peaks in midweek, and only occasionally. So it wasn't a pattern that we could really discern. So we overlaid events. So was there a soccer game going on at the time? Was there a musical concert going on at the time? Was something happening? Was there a bank holiday? Those sorts of things. And to a certain degree, we could see some patterns, but there were still some that broke the mold. It was only when we aggregated weather data that we saw there were peaks were mainly when it was getting hot. And that's because in the UK, when it gets hot, it doesn't do it very often. So when it does, everyone goes out and has a drink. And when you go out and have a drink, there are certain amounts of people that will cause trouble. And so there was an increase in the amount of calls that were happening at the time. But it was a completely unrelated piece of data that we were aggregating with the rest of that data. And it drastically changed the way we viewed it. So you've got to remember, all data is presented with a certain context in mind. There's a reason that data exists. And often it's useful to take data that's seemingly unconnected and layer it over the top and see if that helps create patterns. It's entirely, the weather data was never collected for that reason, but it absolutely solved the problem. But ensure that
oddly enough,
there's a new context. Sure, go ahead, Jim.
Oddly, I was going to say, oddly enough, we've also found some correlation with lunar cycles. And a full moon actually brings out some interesting behaviors in people. At least that's what some of the law enforcement that we've seen in our area has reflected. Yeah,
absolutely. Yeah, it's strange some of the ways that these extra data pieces can suddenly bring a new context and new color to the information that we're being presented.
This brings to question, though, the concept of data modeling. So at some point or another, as you said, you're going to gather this data and you're actually going to make a predictive model that comes out of it. One, how useful is it to go and review that model as you get additional data or as time passes on? And two, is an incorrect model, or what does an incorrect model mean?
Yeah, great question. So in terms of the criticality of reviewing that model, it's absolutely a must. You can't just trust that a model that was built at a certain point in time is always going to be true, because it was built with a limited set of data, and whether it was petabytes of data or yottabytes of data, it's still limited, right? You still only have that finite amount of data when you train the model, and new data is coming in all of the time usually. Look at the pandemic, certainly, but you're looking at something like weather or the fires, all those sorts of things. You can see that kind of the data changes over time, and new biases will get injected into that. New peaks and troughs will get injected into that data. So you need to review it. You need to keep sending that data through the training process and seeing what model comes out the other end of it. The other piece is, very often when you create a model, if you're a human that's validating that model, you'll have your own assumptions about what that model will tell you. And so when you train the model and it tells you something different, the assumption could be, well, the model is wrong. And it's very important to understand that the person doing the training and the assessing is just as likely to be wrong as the model. So it could be that your entire assumptions about what you should see coming out of the model are wrong. They're incorrect in some way. You've either missed some data out, you've added some data, or you've just made assumptions about some data that simply aren't true. So it's very important to not only question the accuracy of the model based on the data that you're seeing, as well as checking it against other means of getting to that same algorithm. So financial trading is a very good example of this. You have models that will do predictive trading, so they'll take a look at the market, seeing what executions are happening at that time, and make predictions based on, last time I saw this happen in the market, this was how certain stocks behaved. They validate that by going back and running those things over historical data and seeing if they can predict what actually happened. So they'll go back and check their homework, as it were. The same is true of any model. You need to firstly check that it's accurate in real life, validated against something that hasn't come through the model, but has come through other means and come to the conclusion you would expect it to. But if you see a model create something different, don't assume the model is broken. It could well be the human being that's making the decision that's got something wrong, either building the model, feeding the data to the model, or simply not collecting the right data in the model. I had a good example where I was doing some work on, we were looking at rubbish bins and deciding whether they were full. So it was video analytics we were doing. And we were collecting all this data around the bins, and we were deciding whether they're full or not. And we were getting a lot of false positives saying the bin was full. And the assumption we made was that when we see a certain dark area, we can see the bag, and therefore the bin must be empty. And so when we can't see the bag anymore and the bin isn't as dark, it must be full. Which worked up until people started putting white bin bags in the bins, and it reversed the model completely. So the assumption was, well, the model is wrong. Well, actually, our assumption about the situation was wrong. We'd assumed people always use certain color bin bags, and actually they didn't. So it gives you a good idea of you constantly need to check.
So the accuracy of the data model is itself data that you will use to adjust your assumptions.
Yes. Yeah, it's a bit like Inception. We can go down as deep as you like, but there's data about data about data. And so it's important to understand that the data you get is surrounded by metadata, and the data that's used to come to conclusions is also itself surrounded by metadata. And all of these things need to get challenged. I mean, you can carry on forever if you've got the time, but the understanding needs to be there that you need to look beyond just the surface of what's being presented to you and look underneath as to what built the mechanism that helped create the conclusions. So absolutely. So I want to look at clean versus raw data. And this is really the kind of last bit to touch on. And we've mentioned it a little bit as we've been through this. Clean data is essentially data as you get it, as you collect it. So it's fresh off the sensors, if you like. So the telemetry about that sick person, it's exactly what the thermometer and the heart rate monitor and the blood chemistry and everything is telling you it is. You haven't done anything to it. It's raw data. When you have that data, you do something to it. So you then interpret it in some way. So you bring them together, you interpret it and say, this is the next stage of data. However, raw data is not perfect. And the reason it's not perfect is because sensors aren't perfect, software's not perfect, and people aren't perfect. And if you're relying on any of those three things, you're going to make a mess up somewhere along the line. Now, it could be that there's gaps in the data. So your sensors stop working for whatever reason. Your patient goes to the bathroom, and so they take the heart monitor off and disappear. All those things mean it creates imperfections in that raw data. Those imperfections have an impact on the processing of that data. So when you see gaps, you need to understand how whatever models or whatever mechanisms you're building to interpret that data treat the gaps. Are they treating it as zeros, in which case you might skew your results, aggregate and averages way down because you suddenly have a bunch of zeros you have to deal with? Are they treating it as minus ones, which could get interpreted mathematically as being the highest number you can get to based on how you've done the programming and whether you're using ints and floats and all the rest of it? So there's lots of different ways that these gaps can impact things. The other thing is sensors go a bit crazy sometimes, and they create spikes where you might see a massive outlier of information. So you see a result you would never expect to see. And then that could be in either direction, right? Positive or negative. So what do you do with those? Do you leave them in because you think, well, actually, it's entirely possible that was actually a result, and I need to make sure I'm aware of that? Or do you clean it? And when you clean it, do you simply drop it, or do you somehow aggregate it? So you average it down and smooth that curve out so it looks a bit more like what you would expect to see. And again, that comes back to exactly what you were saying, Jim, in terms of, do you trust the data that you're seeing, or do you make a judgment call on it? And if you're making a judgment call on it, is it your assumption that's wrong, or is it the data that's wrong because a sensor might be faulty? So all of those things have to be taken into consideration when you're doing that. When you clean the data, you remove those rough edges. You make it much more smoother in terms of when you look at the curves of the data and everything else, which might be exactly what you need to train the model in an efficient way, but it might give you the wrong result because maybe you've cleaned it in the wrong direction, or maybe those outliers that you removed absolutely were critical to finding the outcomes that you were needing. So you're removing what you think are errors, but that might just be, it might be significant in some way. And over time, the amount of those errors building up when they're being cleaned out might prove to be very significant in terms of the interpretation of the model. We got to remember as well is aggregated data. So we saw those reports flowing through earlier. That was all aggregated data, and that relies on clean data rather than raw. The doctor did the cleaning, then the medical professionals did the cleaning, then the politicians did some more cleaning, then the press did some cleaning. So every stage there's that cleaning, and you remove the resolution of that data every time you do that. So you're taking out some of the accuracy every time you do it. You're seeing summaries of it, and it's important to understand that. So when you do have something you need to challenge, go back and see if you can find some of the raw data that actually made those suppositions possible and see what was removed and why. And that goes back to that question we asked ourselves in the last slide. So that's really the difference between clean versus raw. It's very unusual for someone like the press or social media to have raw data available for you. It's normally presented in some kind of clean format where somebody has formed an opinion around it and is presenting it in that context.
Well, I think that's very insightful. I mean, you can get to the point where I've presented a model or I've developed a conclusion based on the clean data or based on the analytics on that clean data, but it might be worthwhile to actually run that same analytics on some variant or some combination of the raw data just to understand whether the same pattern is emerging.
Absolutely. Yep. Yeah, so just to go back and repeat things again and again and again to see whether there's a trend in the data over slightly different data sets each time. And the same happens actually when we're training machine learning models. So when you have a training set that you'll use to train the model, and then you'll pick data that the model has never seen before. Hopefully, if you can do it, random sets from a much larger data set to actually validate the model. So you're running different things through it and you're seeing what those results are. What we see in some cases is if you can overtrain a model, what they call overfitting, which means you've trained it on certain amounts of data to the degree where you smooth the curve so much that there is no curve anymore, and so you've gone past accuracy and you're coming back into to inaccuracy again. So it's possible to do that with data as well, just to summarize it so much that any kind of influence that data has on an opinion is lost to averaging out in summary.
Yeah, another question that comes up on that is you can talk about data and actually looking at the verified facts or the verified assumptions, but can you also gain insight from the flow of the data itself, even if you don't know what the data is? Yeah,
absolutely. So, and that's a really good point. So the path of the data and the kind of iteration of that data through its life cycle will also give you a good idea of how it's come about and how trustworthy it can be and what might have happened. And so if data's been through lots of different steps in its life cycle, you can probably lower the amount of trust you have in it. You can certainly understand that if it's passed through 15 sources and been manipulated each of those sources, the accuracy is going to be skewed in some way. Now, it could be skewed more accurately, it could be skewed less. You won't know that depending on how much you know about the areas it's been through. But absolutely, you can make a determination of the accuracy and the resolution of the data from how close to the source of the data you've actually had access to it and what sort of process it's been through each time, so each of those iterations. And so talking of summaries, just to kind of sum up what we've been saying, data literacy is absolutely something that benefits everyone. Everyone has access to the information, everyone has access to data, and they have it thrown at them on a daily basis by people with opinions about that data. The skill is being able to not ignore the opinion, but treat it with open enough mind that you can go and question it and you can go and understand how they came to the conclusion and whether, given all of the other aspects that have been left out, how you would actually come to that conclusion yourself, or would you come to a different conclusion? We've used the pandemic a lot as an example here. I've thrown another couple in as well just to kind of even things out a little bit. But this information, this data, and this methodology is absolutely transferable to any data, including, as we've pointed out with the IT ops people, data around your organization's IT infrastructure and the logs you're collecting, data around your accounts and how your factories and how your retail outlets are performing. All of this can be challenged with exactly the same methodology and understanding where the data's come from, why it was collected in the context. There are skills being used by data scientists in pretty much every organization that employs them. and the demands will translate to an impact on storage and data platforms. So to bring it back to the kind of SNIA relativity, if you like, asking these questions of data has an impact on how often you access that data. So when you're doing these types of activities, and when you have data scientists that are doing these activities, you will suddenly see random spikes in data that is seemingly irrelevant to you as an administrator, maybe looking at it thinking, well, why is this accessing? And it's because there's a question being asked of that data and something is being accessed in order to provide the context and the validation of that data. So you'll see this more and more happen. As more and more data scientists become prevalent across our organizations, we will see the pattern on our storage begin to change to become more random in a way, but a lot more unpredictable. Understanding data means understanding the metadata around it as well. Where is it from? Who created it? Why did they create it? What data is related to it that can support it or question it and challenge it? And when was it created? How old is the data? Data has an expiry date, believe it or not. So the raw data less so, opinions more so, because they're now influenced by new data that's collected that may change your view. If you go back far enough, we have data to support that we're the center of the universe and the sun orbits us. As you add data to that, we understand that that's slightly different. And so you can see over time, new data will change opinions, will change points of view. And that was it. That was what I wanted to cover. So back to you, Jim.
Okay. Well, we certainly appreciate everybody watching the webcast, and we would encourage you to not only rate this webcast, but also provide us with feedback. We read your feedback, and we use your feedback to improve all the SNIA presentations. This webcast and a copy of the slides will be available in the SNIA Educational Library, and you can see the link there, snia.org/educational library. And I would encourage you to go to the Educational Library and take a look. We have a wealth of presentations and data, many Bright Talk presentations, many white papers, as well as some new video content. And I think you can learn an awful lot from the things that we have here. We will be reviewing this webcast, and we'll be looking at the conversation that Glenn and I had and some of the questions that were asked, and we will be doing a Q&A blog that will be posted to the SNIA Cloud blog, and you can see the link there. And you can always follow us on Twitter at SNIA Cloud. I certainly appreciate everybody's attendance today and everybody's feedback. I can see it coming in. We want to thank you for attending, and we look forward to seeing you on another podcast. Thank you very much.